back to this next video in the geometry video series, still talking about triangles here. So today's topic is going to be the law of sines. Now this is a really important equation, really useful for figuring out the side length or the angle of any triangle. It does not have to be a right triangle. So we're just going to take an arbitrary triangle here, and we're going to name the sides capital A, capital B, capital C. And then the corresponding angles, so the angle opposite the side length. Opposite of capital A is going to be alpha, opposite of capital B is going to be beta, and opposite of capital C is going to be a little lowercase c here with a little tail on it. And these are all angle measures. What the law of sines states is that the ratio of the sine of the angle to its corresponding side is the same for all three sides on the triangle. So put that in writing here. The sine of alpha over A is equal to the sine of beta over B, which is also equal to the sine of our little c here over capital C. So any pair of these is equal to any other pair. And what's really useful about this is if you have one of these pairs, say we have just a triangle with alpha and A, we can figure out the information for the entire rest of the triangle just based on that and one other piece of information, no matter what that information is. So let's look at a quick example. We're going to say that we have a triangle here, and we're given an angle measure of 40 degrees, a side length of 6, and a side length of 8. Well, you can see that we have one pair right here. So the sine of 40 degrees over 6 is going to be equal to, and we're given the side length of 8, so the opposite angle, we're going to call that theta 1. That's going to be equal to the sine of theta 1 over 8. Now we just do a little bit of algebra. We'll multiply both sides by 8, and we'll get that the sine of theta 1 is equal to 8 over 6 times the sine of 40. 8 over 6 simplifies to 4 over 3. And then we can do our inverse trig here to isolate theta 1. So theta 1 is going to be the inverse sine of 4/3 times the sine of 40. And the sine of 40 is a number, so you can treat this whole term like a number that we're multiplying or adding. So if we just plug this into our calculator here, we get that theta 1 is equal to 58.987 degrees. And as I mentioned, you can take this and you can solve for the rest of the triangle. The easiest way to do this is we don't have any information about this side length we'll call x, or this angle measure we'll call theta 2. And it's not a right triangle because the angle measures don't add up to 90 degrees, so we can't have a 90-degree measure here. But we can use the sum of interior angles of a triangle. And we talked about this in another video. But the sum of interior angles of a triangle is always equal to 180. What does that mean? It means 40 here, plus theta 1, plus theta 2, or in terms of an arbitrary triangle, as we mentioned up here at the top, C plus alpha plus beta. That is always going to equal 180 degrees. So if we just plug in what we found for theta 1 right here, 40 plus theta 1 plus some other angle theta 2 equals 180, we can solve for that pretty simply and get that theta 2 is equal to 81.013 degrees. So we can then plug that back into our law of sines, and we say that the sine of theta 2, which we've just solved to 81 degrees, over our side length x, which is what we're solving for, is equal to any of the other two ratios, either sine of 40 over 6 or sine of theta 1 over 8. We'll just choose sine of 40 over 6 because we've already used that. So we'll do sine of 40 over 6. And then here we're actually trying to solve for x. So what we should do is we'll invert the right side, invert both of them. We can actually do that right now and say that x over sine of theta 2 is the same thing as 6 over sine of 40. And because this is a ratio, you can just flip them like that as long as you're on both sides of the equal sign. but we can then multiply both sides by the sine of theta 2. So x equals 6 sine of theta 2 over sine of 40. Plug that into our calculator using 81.013 as theta 2, and we get that x is 9.219. So there we go. We've solved the entire triangle based on just one side length angle pair and a third piece of information.